Good morning, everybody. Welcome back to Coding on Swiboe, the next generation text editor. I have no top of the show business except for warning you that next week there will not be any stream. Yes, there will not be any stream for the whole next week because I will be traveling. I will be at ROSCON or IROS, or actually both. First IROS and then ROSCON in Hamburg. So if you're there, find me and say hi. I would be delighted. Okay, let's get started. We were introducing errors. Well, error handling, that is. Basically, we changed the connect function yesterday to return a result object. And instead of returning the pointer to the client directly, it actually returns, like it takes a pointer to a pointer and assigns this pointer to a pointer if the result is okay. And we want to have that for all of our functions. Hello parts, good morning. You're right on time today, right on time. And yeah, we want to change basically all the functions to always return a result object so that our API is consistent and easy to understand and use. Basically, the result object will tell you if the function call succeeded or not. And I think we'll start out by actually converting all of our individual errors that we have in Rust into error code so that we can return them. So basically we already have one error code, which is success, which is here, right? We have a success one, and now we basically have to create more error codes for this match clause here. So let's move the success error to the front. And now we try to compile, and it hopefully, no, for sure it will complain that we have a non-exhaustive pattern here. And this is actually what we need to figure out. So what sorts of errors do we actually have? Actually less errors than I was expecting. So we can say that we just have those errors, right? Swiboe error disconnected. And basically for all of these we have to return a matching integer number. So we can say we have error disconnected, and that will be a C API error result. And why not give it the error code 1? Who cares? And then we have an IO error. We have a JSON parsing error. And we have a RPC done error. So 2, 3, 4. And basically, is that it though? I think it is maybe all we need for now. Of course, our C API allows for more terrible errors that are harder to detect. For example, the Swiboe disconnect call, it could get some garbage pointer, and then of course it would just fail terribly. What we could do is we could check for null pointer, which is the most likely case for an error, and make sure that when we are returning anything, now we cannot modify that. No. I was thinking if we could introduce some sort like error invalid parameters for the C API, but we cannot do that in all cases. So for now, let's not bother until we find a way of doing it that makes sense. And of course, what is also becoming apparent here is it would be nice if we could provide more information. So for example, here our Rust error actually contains information about the particular JSON parsing problem that Zerde encountered. And it would be really nice if there was a way to give that back to our callers. And we could do that by actually not returning an integer, but returning some structured object. But then you have to destruct the structured object somehow, which is also something that would make the API a little more complicated. One thing that you might do is you might have a global variable, something like the elno variable in C, and then have a API to set additional arguments, like additional information for the error, and then a global function that will return you some information about the error. But that's more complicated than what we need for now. So we'll just trooper on with what we have. Okay, and this was this. Of course, we're not using this parameter, so we might as well ignore it. And same here. We ignore this too. And I think now the compiler should be happy again. No. No. Oh. We're missing a return here, right? And then we also miss a semicolon here, I guess. Apparently not. Okay, then not. I don't think the semicolon would have hurt, but yeah. Oh, I see a couple of new people in the stream chat today. Welcome, welcome. Nice to have you. Okay, so we now are converting all of our Rust errors that we can possibly encounter in this file into errors that we can return to C. And the nice thing about this, if we ever add more error cases to the error class here, this code will stop compiling because we do no longer do a complete match over all possible values. So we will immediately know that something needs to be added to our C API. And that is very nice. That's precisely what we want. Okay. Then let's see. Where do we continue? Let's do Swiboe disconnect next. So Swiboe disconnect will also be changed to return a C API result. And that will actually always be success, right? There's nothing that can go wrong here. It might feel a little pointless to actually add a result value that is always success, but our users cannot know, and in the future this might change too, so that we might need to return an error. So it is definitely good for symmetry of the API to have all the functions, even those that cannot fail, return a result value all the time. And basically we can now change, hello BM Corsa, good morning. We can now change all those calls here for Swiboe disconnect to actually check that it returns a value. The question is, does it make sense? Well, I guess it makes sense. So time for macro again. At the beginning of the line, type assert equal Swiboe success, and at the end of the line, close the brace, go to the next one, jump to the beginning of the line. Great. Okay. And of course, I used the Swiboe success variable here, and we didn't define that yet. So we have to go here, and actually we can just copy over those values from here. So basically, here, maybe. Those are error codes. And do I actually have to, I think I have to say that they are a C in 32.0, right? Time for macro again, find the next column, change it to a equal sign, delete, find the next equal sign, then insert C in 32, find the column and change it to a closing one, go one line down at the beginning, and done. Okay, really nice. And then we also fixed this no-com here, right? We would like a symbolic name for 0. Yes, we have that now, and we called it Swiboe success. And I think that should be it already. Let's see if it compiles. Let's see if the tests run. So it does compile and does do the test run. No, because 0 is not the same as C int 0. Really. What the heck? Okay. Then I guess they are not C int 32s. They are just Python integers. Assertion error 2 is not equal to 1. That is interesting. Where is that? Test connect with invalid socket in line 44. What? Oh, indeed, right? There is an I/O error. If we want to connect to a wrong socket, then we get an I/O error, and this I/O error we have to test for, right? So this is then called Swiboe. Like so. Okay, all tests pass again. And we can continue with the next function call, which is the next one. It is called Swiboe new RPC. Oh yeah, that's really good if that is finally returning an error, right? So yeah, so Swiboe new RPC should actually also return success. You know what? I will actually pull out a small function that I call def expect okay, or let's just call it okay. And it takes a result and it does asset equal Swiboe success to result, something like that. And then we can actually change all these longer calls here. So basically wherever we have asset equal and then success, we can change that to change the opening brace to okay. Nope, I messed it up. Okay, here it was actually still correct, but it's basically always the second argument that we want to test, not the first. Okay, so let's change it again, self, okay, and then we go here and delete till the next comma, and now I got it. Vim macros in the morning. Shouldn't do that. And that still works, right? Oh, what? What? 9:30 in okay? What did I do? Oh, funny. No, I cannot call okay and okay. So we expect this to be Swiboe success, right? Yeah, okay. Back again. And where was I working on? Oh, new RPC, right? Basically, all of our new RPC calls should work. Here we can say this should be okay. So it should be this and this and this too. Wait, that is wrong. It should be self okay. Wow. There are more calls to this function than I was thinking there were. So we got that, and now we have to change, of course, the Rust part to, okay, where's it? New RPC, where is it? Here it is. So what do we do in here? We basically, that is safe, well, not safe, but we do not expect that to fail, let's put it that way. We are now returning a C API result object. And here we don't know if it works or not, but we have no way of actually investigating that, right? It will either crash when you call a function if the client that we pass in is invalid, but we have no way of actually checking that the class that we get is a real client. That's unfortunate, but that's the way it is. And here we have, this can definitely fail, right? We can get a non-UTF string object, and then this call will not work. Though, of course, right now C string to string is using unwrap, so it is always working. But yeah, that is definitely not good. And then we call new RPC on client, which does what? So client mod new RPC. That does an RPC call and waits for it to complete, and it expects it to work. Yeah, so that's very straightforward, right? We can just like basically we are returning a C API result here, and we have this nice macro that we wrote yesterday. That's called try C API that returns that will convert to a, why is it called C API? So that will return, convert an error into a C API error code. And here at the end, we can just like write success. And that should not be called try C API, that should be called try C API. Not ABI, but API. Okay, so let's compile that real quick and see if it still passes all the tests. And then we'll look at the C str to string. And once we're done with that, I actually want to interrupt because I wanted to merge master today and I forgot all about it. Or we could also fix those compile errors here. So variable does not need to be mutable. That is true. Doesn't need to be mutable. And in 240, the box context also doesn't need to be mutable. And why do I actually box it in here? There's really no need for that. We might as well box it directly down here. Oh, I did it because it is not an unsafe operation, I guess. Nah, I think it's fine. And apparently when I did my OK changes, I messed something up. Yes, it is true that there are no objects OK. There are objects O underscore OK. So like that, right? And it runs again. Okay, what did I say now? The next thing I wanted to do is changing the conversion of Python strings to C-like strings, right? So basically this here, a C string to string. And now I'm wondering, do we always have, basically if Python passes us a C char object, do we own it? Do we have to free it, or is Python freeing it? I think actually that Python is freeing it, and we probably make unnecessary copies every time. So basically we get a C buffer object, and what we do is we first create a C str object from that, and then we here we actually create an unowned buffer. Yeah, and that's actually what we should return, right? Basically, I remember what the problem was. I couldn't remember the lifetime. Like I couldn't figure out the lifetime, right? Basically, when I say I have a cbuff that is a pointer to a const c char, and I would actually like to convert that to some sort of reference, because a reference has a lifetime, and then I can actually return something like this, right? I can say, well, we return a str object here, and we could do that if we knew that we would get in a C char reference, something like that, right? Yeah, I think actually that would be nice, because then we know that this has a lifetime and this what is returned also has a lifetime like that. And I'm not sure if that is actually possible. And I want to test that out by making a separate function so that I don't have to change all the call sites everywhere. And then we call that cstr to str. Why not? And that takes not a const pointer anymore, but it takes a reference to a cchar and it returns a reference to a string. And then we just do not, like here this into was actually turning a str into a string object by making a, like allocating a new buffer and then copying over the data from the slice into this string object. Oh, but that is still correct. We do not want to unwrap. So let's first see if that builds even. It seems to be building, but of course it's complaining that it's not used, which is true. But we can change that by using it down here, right? We say we don't want a cstr, we just want a str, a slice, not a string, a slice. And now we actually have a const pointer to a cchar object. And here we actually want a reference to a cchar object. And I'm not sure if that is an unsafe operation or not, but the compiler will tell me. Aha. Expected a reference to a whatever that is, a I8. Interesting. And yeah, so we have to actually mem transmute that. So LPC name reference is mem transmute. Can I do it like this? So I guess that won't work, right? If I say this is a reference to cchar, and we just assign it like that, that won't work, I guess. And I'm also not sure if I now, yeah, I don't think that works. It says mismatch types. And if I now mem transmute it, it will complain that this is unsafe, right? And I can wrap it in an unsafe block, and then oh, it's actually not complaining that it's unsafe. That comes as a surprise. Ah, there we go. Now it's complaining that it's unsafe. So I can wrap that in an unsafe block, and now that will obviously compile. But will it run? That is the question that I'm asking myself, and I feel like it shouldn't. Oh wow, it does run. Awesome. So it does work. That's coming as a surprise. A pleasant surprise, but a surprise nevertheless. And while we're on it, let's introduce error handling here. So basically what we will return here is a error, not an error, a result. And it will be a Swiboe result, right? Because why not? Truly though, does it make sense to actually take a reference to a cchar, or should we just take a C string object from the start? And I think we should probably take a C string from the start. So basically what we can say is we take here a reference to a C str object. and then this is actually a C-str, and we can remove this. And then down here we can say, instead of doing this transmute, we just say directly RPC name is now a C-str from pointer, from raw. How's it called? How's it called? From pointer. Filter. And it takes the RPC name. Right, and that is probably still a unsafe operation. Not entirely sure about that. Let's see. I mean, it must be an unsafe operation, right? We take some arbitrary pointer and turn it into a C string. That should be an unsafe operation. So what in line 52 expected? Okay, so that has to be an OK for now. Of course, that makes no sense to have an unwrap inside of an OK, but I want to deal with the argument first before I think about the errors. Okay, we're getting there. So now we get back an RPC name, and this we actually have to try CAPI, right? If that fails, then we would like to return an error code. And yes, that was actually what I was looking at. And I think that we might actually, yeah, let's do that up here. Let's do all the conversions at the beginning. Unsafe. Okay, so will it blend? Yes, it does. Okay, now let's look into the error. Basically, we do a string from UTF-8 here, but we are not unwrapping. Actually, we're just returning this value. I think we actually have to try to return this value and then return OK, because try actually converts from errors. And now I think it will complain that we do not have some conversion from, yes, we don't have a conversion from core string UTF-8 error, and we have to add that, and we added our error, like that is the generic error class for Swiboe, and here we actually have to add a new error, and we call it invalid UTF-8. Just a second, be right back. Okay, back. Sorry for that. My vacuum started up again. I think it's the second time on stream that this is happening. And yeah, invalid UTF-8, and we need a from clause for that. We're converting from string UTF-8 error. Let's look up this error. There's actually a standard string from UTF-8 error and a standard string slice from UTF-8 error. Are you kidding me? Are those two different errors? Really? Really? Well, okay, if you say so. For now, we only need one though. We only need standard str UTF-8 error, and then down here that must also be this. And what do we return? We just return invalid, unknown invalid, how do I call it? Invalid UTF-8. Okay, so that should handle that, but of course now the compiler should complain, Yes, we added what? Use of undeclared type or module standard string. Is it like so maybe standard string? Yes, and now it is unhappy that we don't use invalid UTF-8 in all the different error clauses. For example, here we need to add it invalid UTF-8, invalid UTF-8 string and count it. And there must be other places. There's definitely one more in our C client. Yes, that's true. We're not using this variable. Might as well not name it. And here, non-exhaustive patterns. And this is exactly what we expect. Here we have what? Where is our library? Here it is. So up here we have to add Swiboe error invalid UTF-8, and we return error invalid UTF-8, which of course is not yet defined, so we have to define it. Error invalid UTF-8, and that gets the error code 4. And in the Python code, we also have to mention that. Error invalid UTF-8. It got the error code 5, right? Yeah, it got the error code 5. Okay, let's build again. And the question is now, does this warrant a separate function? I guess it does. I mean, it is mildly complicated. So then you could also say that we might as well just take the const char as we did up there and pull out the unsafe again, and then we only have to call this function. Yeah, I think that's better. API design is hard. It is hard. Basically, we bring this one back, and then we can change this down here to actually we can directly take the RPC name again here, and then this function looks really nice, right? There is error handling, there are a couple of tries in here, there is no unwrap, and that looks really, really nice. Oh, now I remember again. I remember why I actually had that. Yeah, I had that because then I have a lifetime associated with the string, and this is exactly what I want. Yeah, so I cannot really pull that out here. Okay, run the test again. Okay, that works. And now let's get rid of this function here. This function can now be replaced through basically we have to have a socket name C string, and that is unsafe C string from pointer socket name. And then we call cstr to str here on the socket name C string. Like so. And now the socket name is no longer a string, it is a reference, and that's fine because we only use it as a reference. So where else are we using this function? Down here. We now have a JSON buffer C string, JSON C string from pointer JSON C buff, and then we say this is C string to string. This is a JSON string object, and actually we don't need the references here. And up here we don't need the references either, right? Because that is already a slice. Yes. Okay, where was that now? Where was I? Somewhere here? Yeah. That's an interesting argument. I was not thinking about that. So basically what we have here, we get the JSON string object, we convert it from a UTF-8 into a Rust string slice. But actually here we try to convert it into a JSON value. So basically here we pass it into, we pass it as valid JSON. And if this is not working, we're actually blowing up. We're not returning an error code. We actually blow up directly. And we did that with the argument that invalid input to functions should blow up because it is a programming error. Now though, if we get an invalid UTF-8 sequence, we actually don't blow up, we actually return an error. And that is, that's questionable, right? Why should we return an error on invalid UTF-8 and blow up on invalid JSON? And that is actually something that I'm now a little bit torn about. Should we also blow up on invalid UTF-8 like we did before? Or should we also return an error on invalid JSON? I don't know. For now let's continue on the path that we set out ourselves and add a to-do here. We return errors on invalid UTF-8 but blow up on invalid JSON. That is inconsistent, right? Inconsistencies are not good in programming. Eventually we have to fix them. And probably the right argument is that you can say, well, the C API must not crash, and then it is the higher level abstraction, so the Python API can then crash or can throw an exception, and then it's up to the user to check the input to its function or not. Yeah, I'm not sure. Okay. So where else do we have C string to string? Down here again, and that's exactly the same thingy again here. We have a JSON string and then we have a JSON value. Actually, I feel like we should probably pull that out. So we need a new function that takes a C string to JSON object, and that takes a C string, and that is a reference to a C string, and it returns a result of a asserted JSON value. And that's essentially all of this. So we get a C string object already. And then we have a JSON string, and then we convert this to a JSON value, and then return OK. And we have that here, a JSON string, a JSON value. So here we can say our JSON value is just C string to JSON, and we have C string, C string. Whoa, whoa, whoa. And then this goes away, this goes away. And this is a try C API call. Oh, and we have one more error handling here. I think we can just wrap that in a try call as well, but I want to make it compile first, and then we'll look into that. And this actually is a utility functions. Utility functions always go to the top for me, because I'm a C++ programmer by heart and not a Java programmer, right? Same thing here. JSON value is constructed exactly in the same way. And here we have once again a error name, a call to C string to string. Wow, there are always so many here. So here we have a JSON details object, and that is also C string to JSON, and that takes a cbuff, oh, a C string details. And C string details is unsafe C string new C buff details. And here that's some try C API, like so. Oh man, so many calls to this one function. Okay, cbuff error name, and cbuff error name, no, C string error name is unsafe C string new cbuff error name. And the error name then is try C API C string to string of C string error name, and by reference. And I think actually this might not work the way I expect. Oh, maybe it does. Oh yeah, yeah. Yeah, it should. That should work. C string to string. Here again, RPC name. That RPC name cbuff is unsafe C string new RPC name. And then we say RPC name is try C API RPC name cbuff. And here we have try C API C string to JSON args C string. Nearly there, nearly there, I think, I hope. What are you not liking here? Oh, semicolon missing. Yay! So we can kill this function, and now we have to fight the many compile warnings that we probably created here. JSON cbuff that is just called cbuff here. And then 133 C string details, C string details. And that should take a reference, I think. Okay, in 46 we actually return a Swiboe result. Okay. In this expansion of try-C API in 47. Oh, that is actually just a regular try, right? Yeah, absolutely. Guess I won't merge master today. This takes longer than expected. And 62, right, this is a try-C API call. Wow, so many errors. Mismatch type in expansion of 103. What are you unhappy about? Expected nothing, and I found an integer 32. Well, that is confusing. That is confusing, right? In this expansion of try-C API, what did I do wrong? So we call cstring to JSON, which is taking a cstring and returns a Swiboe result of an object. Yes. Then we try to unpack this object. Yeah, we unpack the string into a JSON string, and then we create a JSON object out of that, and then we return that. And I don't get why you don't like it. Expected nothing, found one. Oh, of course. I started using try-C API in functions that are not actually returning a result yet, right? C API result. Nocon update Python to new return value. Yeah, of course. That was stupid. But here actually, that's here is actually super terrible. Well, you know what? Let's not do that. Instead, we just unwrap. And here too. Until we actually properly introduce error handling in those functions, unwrapping is much easier. Wow, I use it in many places now. Let's try again. Unclose delimiter. unclosed delimiter. True. Still unclosed here. Okay. More compiler errors. No associated item named new found for type C-str. Oh, it's not called new. It is called C-str from Pruto. And I apparently still use the try call in places where I should not yet. More places. And here it's actually fine. If and else have incompatible types in 116. So this is returning a null pointer, and this is, yeah, that's fine. Not a null pointer, but a JSON object. And not all control paths return a value in 95. And that is actually the context update call, which I did change, but apparently not everywhere. Did I actually change it in Python 2 update? No. No, I did not yet. So actually that should be a result. And here we expect this to be okay. And I think we're converging. We are converging, so it compiles and does it build, not build, but do the test run. Test. Yes, they still run, so seems like we're golden. But we also would like to introduce some errors. For example, here we would like to try out a update call on an RPC that is already done. So I'll cut the stream here. Went longer than I was expecting. As usual, I'll stick around until I posted the work we did today in the stream chat. So if you have any questions, post them in the stream chat right now. So this is the work we did today. Work done on stream. Okay. There are no questions in stream chat. Thanks for watching, people. We reached a viewer high of 9 people today, which is quite a lot. Okay, that was the last stream for this week, and next week there will not be any streams because I'm traveling, as said, and I'll see you guys then on the 5th, I think. Is it the 5th? Yes, on the 5th of October at 8 AM European time as usual. Thanks for watching and see you then. Bye!